All right. Nothing makes you feel better than graphing phase shifts and vertical shifts. I mean, think about it. Hardly anything makes me feel better than that. So let's do that a lot. Here we are. This problem right here, rated M for mature, and we're going to have to graph this on a coordinate system. So let's make our coordinate system right now. And I'm going to make this thing huge because all the work is pretty darn visual on this problem. This thing is going to be shifted up, so I'm going to strategically draw my graph sort of like that right there. Looks pretty good. I don't know if that's a little bit downhill or not, whatever. We're start filling these blanks in. Now, I'm not going to give you the blanks as far as tests and stuff goes. You're just going to have to kind of do it on your own. Amplitude would be this number here. That's 6. I'm going to start filling this in. The frequency is the number in front of theta, and that's, of course, 1 theta. Sometimes you'll see a 2 here or a 4 here or 1/2 or something. It's 1. So the frequency is 1. Therefore, the period is 2 pi over 1. That's the formula for that, which is 2 pi. The phase shift. The phase shift is the inverse of this. So it's going to be negative pi over 3 divided by the frequency, which is 1. So that's just going to be negative pi over 3. The vertical shift is going to be plus 2. Okay, so what we're going to do, like yesterday, is we're going to draw, and I'm going to try to color code this kind of like I did yesterday, the midline of this. So I'm going to grid this thing off, and we have a big amplitude. It is 6. So this thing is going to go all over the place here. So let's just grid this off. 1, 2, 3, 4, 5, 6, 7, 8. And we'll call that 8 right there because I know it's how this is going to turn into. This will be 2. You can see where I'm going with this probably. Our amplitude is going to go from this midline up 6 and down 6. Okay? So I'm actually going to continue this. This will be 1, 0, negative 1, negative 2, negative 3, negative 4. So it's 6 units. I'm going to delete this. It's 6 units here and 6 units here. And that's how that works. My midline, I like to make it in this groovy purple color. We'll make it go across. Kind of like this. As quick as I can. There it is. And then making these little boundary fence lines. The top. So I know the range of this graph. And down here is very helpful. Instead of trying to graph this on the axis itself and then moving it up and down and sideways, we'll just graph it on the purple line because that's its shift, its vertical shift. It's up 2. Okay, time to put this in intervals here. Our period is 2 pi. So that means we can go in terms of halves. So that's pi over 2, pi, 3 pi over 2, and 2 pi for now. So we're going to put our baseline graph on here. It is, we'll do this in kind of a darker orangish color. And it's a sine function. It's going to start right here and go up. This is our base graph. It's going to go up to here. All right, like that. And we're just playing connect the dots here for now. So it's going to go down to here and then back up to here. So it's going to go like so, come down to here, hit that point, and then come up to about right there. And I totally hosed that. Let me do it again. It's going to come up to the purple line here. There we go. Because that's the point it's going to end at. Starting here. Yes, that's right. Okay. Now what we got to do is shift this back a third. Oh, great. Isn't that just fantastic? Because our scale is in halves. So this would be negative 1/2 pi. And if we're shifting it back a third, well, that doesn't get to a pi. Because think about it in decimal form. I mean, this is 0.5. We're coming back 0.333. So I'll do this in red so you can really see what's going to happen here. I'd say just kind of eyeball it right there. If you have graph paper, it really helps. Really, really helps because you can grid that off. But this would be maybe negative pi over 3. It would appear in front of that. So if you have yours all the way back here or something, you've messed that up. You could resize this. You could redo the grid however you want to do it. I'm going to show you how to do it without doing that. So you'll see that from this point, I went back a distance that was about this big right there. Okay, that big. So my new starting point is going to be right through here. There's my new y-axis kind of thing going down through here. So my new dots, I'm going to play a game. Like I had a student come in and says, well, I just need to know where to put the dots at. You're going to go from here back a third. You're going to go from here back a third. So I'm going to put like a little dot right there, just so I can visually mark that. I'm going to come here back a third. The proportion's going to be exactly the same here, and then about right in here. All right, and then go up to your purple line. Maybe just put those dots in there, just so you have like a little bit of a baseline of how this is going to go. And it's just going to basically follow the path of this orange curve here, except you're going to go up now to right about there, hitting it, peaking right there. Okay, I'll really bold that one. And then it's going to come down and cross through right here. Bless you. It's going to come in here. Preserved on the internet forever. And then it's going to come down to here, to the bottom, right about there. Don't like it. Might as well do it neat if we're going to do it. Down to about right. That looks exactly the same, but okay. And then come up to here. Yeah. And I think what happened was my scale got a little bit off there, but that is the idea. So this final dot will be right here, and we have our basic graph. So I just think my scale kind of got a little bit longer as I went out through here, and that's why this distance here is a little bit greater than that distance right there, but I think that's irrelevant. If you do this on graph paper, and this is a hand sketch, so it's kind of difficult. So let's try this on graph paper. Have a good one.